The quiet life of black holes. What if the darkest objects in the universe aren't violent monsters, but quiet, patient sleepers? Black holes don't scream, they don't chase, most of the time they simply wait. Tonight we're slowing down to listen to their silence and discover what really happens around them. Before we begin, take a breath and settle in. And if calm science journeys like this help you relax or drift off, subscribing gently supports this quiet space of curiosity we're building together. The birth of stillness. In the beginning, black holes are not quiet at all. They are born from chaos. Imagine a star many times heavier than our sun. For millions or even billions of years, it shines steadily, balancing two powerful forces. Gravity pulls everything inward, trying to crush the star. At the same time, nuclear fire in the core pushes outward, holding the star up like an invisible cushion. This balance keeps the star calm and bright, but nothing lasts forever. Eventually the star runs out of fuel, the nuclear fire fades, and when that outward push weakens, gravity finally wins. The star collapses under its own weight. In just a moment, its core falls inward faster than anything we can truly picture. The outer layers explode outward in a massive supernova, lighting up the galaxy like a cosmic farewell. What remains is something small, dense, and deeply strange. If the core is heavy enough, it collapses into a black hole. At first, this newborn black hole is surrounded by noise. Gas swirls violently around it. Light flashes. Matter heats up as it spirals inward. From far away, this can look like one of the brightest objects in the universe. Some black holes shine not because they emit light, but because they tear light from the matter falling toward them. But this loud phase does not last. Over time, the nearby gas thins out. The easy meals are gone, the fireworks fade, and slowly the black hole enters its most common state. Quiet. Most black holes in the universe are not feeding. They are not ripping stars apart, they are not glowing. They are simply there, resting in the dark, barely interacting with the space around them. Our own galaxy, the Milky Way, has a supermassive black hole at its centre. It is called Sagittarius A star. It has a mass about 4 million times that of the Sun. That sounds terrifying. But right now it is calm. It is not actively swallowing stars. It is not blasting radiation into space. Astronomers describe it as quiet, and this quietness is important. A black hole does not roam the universe like a predator. It does not suck in everything nearby like a cosmic vacuum cleaner. If our sun were magically replaced by a black hole of the same mass, Earth would continue orbiting almost exactly the same way. The black hole's gravity at a distance would feel no different. The danger of a black hole comes only if you get very close, very close. This brings us to one of the most misunderstood ideas about black holes. Their gravity is strong, yes, but not infinite everywhere. It grows stronger as you approach, just like any other object with mass. The reason black holes feel so extreme is because all that mass is squeezed into an incredibly small space. At the center of a black hole is something we don't fully understand. We call it a singularity. According to our current math, this is a point where density becomes infinite and the laws of physics break down. Space and time curve so sharply that our equations stop working. But here's the quiet truth. No one has ever seen a singularity, and no one knows what it truly is. Everything we say about it comes from theory, from equations, from careful thought experiments. Some scientists believe the singularity is real. Others wonder if it's a sign that our theories are incomplete and that something softer and stranger waits beneath. Around the black hole is the event horizon, This is not a physical surface, it's more like a boundary in space. Once something crosses it, it cannot come back out, not even light. From the outside, an object falling toward a black hole appears to slow down as it approaches the event horizon. Its light becomes redder and dimmer. Time itself seems to stretch. To a distant observer, the object never quite crosses the line. But for the falling object, time feels normal. It crosses the event horizon without noticing anything special. No wall, no sudden shock, just darkness ahead. This difference in perspective is one of the strangest and most beautiful ideas in modern physics. Time itself flows differently depending on where you are and how fast you're moving. Black holes make this fact impossible to ignore. And yet, despite all this mystery, most black holes spend their lives doing very little. They drift quietly through galaxies. They sit at the centers of star systems. They wait. Some are stellar mass black holes, formed from single stars. Others are supermassive, weighing millions or billions of suns, shaping the motion of entire galaxies. There may even be intermediate black holes, quietly hiding in star clusters, still waiting to be fully understood. The universe is likely filled with black holes that no one has ever seen. We detect them only indirectly, by watching stars orbit something invisible, by noticing gas heating up for no obvious reason, by sensing ripples in space-time when two black holes collide and merge, sending gravitational waves across the cosmos like gentle vibrations on a cosmic pond. Even these collisions, among the most violent events imaginable, end in silence. After the merger, the new black hole settles down, the vibrations fade, space becomes still again. What remains is a heavier, quieter black hole, carrying the memory of the collision in subtle distortions of space-time. Black holes are not holes in space the way we imagine holes in the ground. They are objects, places where matter has collapsed so completely that space and time themselves are bent into a deep well. And yet they are patient. They do not rush. They do not need to feed constantly. They are content to wait for millions, billions, even trillions of years. Some scientists believe that black holes may be among the last objects to exist in the universe. Long after stars burn out, long after galaxies drift apart, long after light grows faint, black holes may remain, slowly and quietly fading through a process called Hawking radiation, losing mass one whisper at a time, but that story comes much later. For now, it's enough to know this. Black holes are not always the loud destroyers we imagine. Most of the time they are silent companions of the cosmos, ancient, invisible, calm. They are reminders that the universe is not always about explosions and speed. Sometimes the deepest mysteries are hidden in stillness. And in the quiet life of black holes, the universe teaches us how to wait, waiting in the dark. After their noisy birth fades, black holes settle into a long, patient life. This stage is not dramatic, it is not fast, it is mostly about waiting. A quiet black hole does not glow, it does not announce itself. If it were drifting alone through empty space, we would have no easy way to find it. It would be perfectly dark, perfectly silent, and almost impossible to notice. This is why scientists believe the universe may be filled with countless black holes we have never detected. They are hidden in plain sight. Most black holes spend their time gently influencing the space around them through gravity alone. Nearby stars move in steady paths, orbiting something they cannot see. Gas clouds bend slightly, as if guided by an invisible hand. Nothing dramatic happens, no fireworks, just slow motion stretched across millions of years. In many ways, black holes are excellent listeners. They respond to what comes near them, but they do not go looking for trouble. Matter must wander close on its own. A star must drift too near. A cloud of gas must slowly fall inward. Without that, the black hole remains calm. This idea surprises many people. We often imagine black holes as hungry beasts constantly pulling everything toward them. But gravity does not work like desire. It works like distance. The farther away you are, the weaker its pull. A quiet black hole is no more dangerous than any other object with the same mass. This calm state can last for unimaginably long stretches of time. Millions of years pass, then millions more. Galaxies slowly change shape. Stars are born and die. Planets form, cool, and sometimes disappear. Through all of this, black holes remain, steady and unchanged. They are some of the most stable objects we know. Even when matter does fall toward a black hole, the process is slow. Gas does not drop straight in. It spirals, it circles, it heats up as friction builds. This creates a disk of glowing material called an accretion disk. But if the flow of matter is thin and gentle, the light is faint. From far away it may barely be visible. Silence returns quickly. At the center of most galaxies lives a supermassive black hole. For a long time, scientists wondered why galaxies look the way they do, why stars move in certain patterns, why galaxies grow and evolve. Slowly, evidence began to point inward. Black holes are not just passengers in galaxies, they help shape them. A quiet, supermassive black hole still holds enormous influence. Its gravity helps anchor the galaxy's core. It affects how gas moves. It may even help regulate how many new stars are born by gently heating or stirring nearby material. But this influence is subtle. It is like the pull of the moon on Earth's oceans. You don't see it happening moment to moment. Yet over time it shapes tides, rhythms and cycles. Astronomers have found a strange connection between the size of a galaxy and the mass of its central black hole. Bigger galaxies tend to have bigger black holes. This suggests a long, shared history, where galaxies and black holes grow together, slowly adjusting to each other across cosmic time. Still, even with all this importance, black holes rarely make noise. The universe is mostly quiet. Occasionally, two black holes meet. This usually happens when galaxies collide. Their stars mostly pass by each other without touching because space is so vast. But their central black holes sink toward the middle of the merged galaxy. Over millions of years, the two black holes spiral closer, circling each other in a slow, graceful dance. As they draw near, they begin to shake space-time itself. These shakes travel outward as gravitational waves. They are not sound, they do not move through air. They are ripples in the fabric of space and time. By the time they reach Earth, they are incredibly faint, so faint that we needed instruments of extreme precision to detect them. In 2015, scientists finally did. For the first time, humanity heard the merger of two black holes. It was not loud, it was more like a soft chirp, a brief whisper from billions of light years away. A confirmation that black holes really do collide, and that space-time really does ripple. Then once again, silence. The merged black hole settles down. The ripples fade. The universe returns to its quiet rhythm. What's fascinating is how calm the final result always is. No matter how violent the merger, the end state is simple. A single black hole defined by just a few properties: mass, spin, and electric charge. Everything else about the past is hidden behind the event horizon. Physicists sometimes call this the no-hair theorem. It's a poetic way of saying that black holes do not carry visible details of their history. They forget. or at least they hide their memories extremely well. This makes black holes feel almost meditative. They absorb complexity and return simplicity. Chaos goes in, stillness comes out. Some scientists wonder if this forgetting is real, or if information is somehow preserved in subtle ways we do not yet understand. This question touches the edge of physics, philosophy, and even our understanding of time itself. For now, the answer remains unclear. What we do know is that black holes are masters of patience. They can wait longer than stars, longer than galaxies, longer than almost anything else in the universe. If the universe continues expanding forever, black holes may outlast all other structures. Long after the last star fades, black holes may still drift through the dark. Slowly, incredibly slowly, they may begin to shrink. According to a theory proposed by Stephen Hawking, black holes are not perfectly black. Over vast spans of time, they leak tiny amounts of energy as radiation. This process is unimaginably slow for large black holes. A stellar black hole would take far longer than the current age of the universe to evaporate. But given enough time, even they may fade. If this is true, the final act of a black hole is not an explosion, but a whisper, a gradual release, a quiet goodbye. In this way, black holes mirror the calm style of the universe itself. Big events are rare. Loud moments are brief. Most of existence is made of waiting, drifting, and subtle change. When we think of black holes this way, they feel less frightening. They are not cosmic villains. They are not enemies of light. They are part of the universe's way of balancing extremes. Where matter becomes too dense, nature responds by bending space and time, creating something stable, quiet, and enduring. Black holes remind us that not all power needs to shout. Some power rests, some power waits, and in the deep darkness of space, surrounded by silence, black holes continue their quiet lives, unseen, unchanged, and endlessly patient, holding on to the universe's secrets without ever rushing to tell them. Time slows near the edge. As we move closer to a black hole, something very strange begins to happen. It's not just space that bends. Time does too. Far away from a black hole, time flows in a way that feels normal to us. Seconds pass, minutes drift by. Cause follows effect in a steady rhythm. But near a black hole, this rhythm starts to stretch and soften like music slowing down at the end of a song. This isn't science fiction, it's real physics. Einstein's theory of general relativity tells us that gravity and time are connected. The stronger the gravity, the slower time moves. On Earth, this effect is tiny, but it's real. Clocks on satellites tick slightly faster than clocks on the ground. Scientists must correct for this difference, or GPS system would slowly drift and fail. Near a black hole, this effect becomes extreme. Imagine a clock hovering close to the event horizon. To someone far away, that clock appears to tick slower and slower. Each second stretches longer than the last. The closer the clock gets, the more time seems to freeze. From the outside, it never quite stops. This creates one of the strangest illusions in the universe. If you were watching an object fall toward a black hole from a safe distance, you would never see it cross the event horizon. The object would appear to slow down, fade, and eventually freeze in place, its light stretched thin and red until it disappears. But from the object's own point of view, nothing special happens at the horizon. It falls right through. This difference in perspective is not a trick. Both views are correct. Time truly flows differently depending on where you are and how strong gravity is around you. Near a black hole, time bends so sharply that our everyday ideas begin to fail. This makes black holes feel like edges, not just of space, but of time itself. Some scientists describe the event horizon as a one-way door in time. Once crossed, all the possible futures point inward. Moving away is no longer an option. The direction out becomes as impossible as moving backward in time, yet even this is described calmly by the equations. No alarms ring, no cosmic warning sounds. The universe simply changes the rules quietly. If you were falling toward a large black hole, especially a supermassive one, you might not feel anything unusual at first. The gravity near the horizon could be gentle. There would be no sudden pull, no crushing force. Space around you would look strange, warped and darkened, but your body might remain intact for a while. This surprises many people. Black holes do not always tear things apart instantly. The dramatic stretching effect, sometimes called spaghettification, becomes intense only very close to the center. For huge black holes, this violent region lies far inside the event horizon. By then, there is no return. But again, this violence is not loud. It does not come with explosions. It is a quiet, unstoppable stretching driven by the geometry of space-time itself. From the outside universe, none of this is visible. All that can be seen is the slow fading of light. This leads to deep questions about what information means in the universe. If something falls into a black hole and disappears from view, where does its information go? Is it truly lost? Or is it hidden on the surface of the event horizon in some subtle way? Physicists have argued about this for decades. Some believe information is preserved, encoded in tiny fluctuations on the horizon itself. Others think it may escape slowly through Hawking radiation. The truth is still unclear, and the debate continues quietly, just like the black holes themselves. What we do know is that time near a black hole does not behave like time anywhere else. For a black hole, the future is deep and long. From our perspective, black holes evolve incredibly slowly. Their growth takes millions of years. Their evaporation takes far longer than the current age of the universe. They exist on timescales that stretch far beyond human intuition. This slowness gives black holes a strange calm. They are not rushing toward an ending. They are not in a hurry to change. They simply exist. Bending time around them like a slow-moving river bends reeds along its banks. Some scientists wonder what this means for the ultimate fate of the universe. If time slows near black holes, could they act like time capsules? Could they preserve traces of the early universe long after everything else has changed? These ideas are speculative, but they show how black holes invite us to think differently about time itself, not as a ticking clock, but as a flexible dimension. In everyday life, time feels fixed. We cannot pause it. We cannot stretch it. But the universe does not share this limitation. Near massive objects, time slows. Near black holes, it nearly stops. This tells us something quiet and profound. Time is not universal, it depends on where you are, and black holes are places where this truth becomes impossible to ignore. As we drift near the edge of a black hole, we are reminded that the universe is not built for human intuition. It is built from deeper rules, rules that remain calm and consistent even when they produce strange effects. Nothing breaks, nothing panics, space-time simply curves and time flows differently. This calm consistency is what allows scientists to study black holes at all. Even at the edge of the unknown, the universe follows patterns. Equations still work, at least until we reach the deepest center, and that center remains hidden. The event horizon keeps its secrets well. It marks the point where our ability to observe ends, but not where reality ends. Beyond it, space and time continue in ways we do not yet understand. For now, we stand outside, watching clocks slow, light fade, and motion stretch into stillness. And in that slow fading, black holes teach us a gentle lesson. Time is not something we move through. Time moves with us. It bends. It softens. and near the quiet giants of the universe, it almost learns how to rest. Inside the silence, beyond the event horizon, the universe becomes deeply quiet. Not quiet in the way a room is quiet or the way night settles after a long day. This is a different kind of silence. It is a silence where information stops reaching the outside world. A silence where light no longer carries messages outward. A silence that belongs entirely to the black hole itself. From the outside, nothing new can be learned about what happens beyond this boundary. The event horizon acts like a curtain. Once it closes, no signal can pass back through. This is not because something blocks the signal, but because space and time themselves are shaped in such a way that escape is no longer possible. Inside, every possible path leads inward. Time, which once felt like something flowing forward, now points in only one direction, toward the center. This idea is hard to picture, because we're used to thinking of space as something we move through freely. We can go left or right, forward or back. But inside a black hole, the roles of space and time become strangely mixed. Moving toward the center is not a choice. It is as unavoidable as moving into the future. This does not mean the inside is chaotic. According to the math, it is calm in its own way, ordered, ruled by precise equations. The confusion comes from our intuition, not from the universe itself. If a traveller were falling inward, they would still experience moments, thoughts would still form. Physics would still operate locally, at least for a while. The laws that govern atoms and light would not suddenly turn off. The universe would not announce that something impossible is happening. Instead, everything would feel strangely normal. This is one of the most unsettling truths about black holes. The transition into them is not marked by drama. There is no sudden tearing of reality at the horizon. No visible boundary, no cosmic warning sign, just a quiet crossing. But deeper inside, the geometry of space-time grows more extreme. The stretching forces increase, distances behave oddly, directions lose their familiar meaning. What was once ahead becomes less clear. What was once later begins to blur. At the center, according to our current understanding, lies the singularity. This is where our equations stop giving sensible answers. Density becomes infinite. Curvature becomes infinite. Time and space, as we define them, lose their structure. This is not just a place we cannot visit. It is a place we cannot fully describe. Some scientists believe the singularity is real, a true edge of physics. Others suspect it is a sign that our theories are incomplete. Perhaps quantum effects soften the collapse. Perhaps the singularity is spread out. Perhaps something entirely unexpected waits there. At the moment, we do not know. What we do know is that black holes challenge the idea that the universe must always make intuitive sense. They show us that reality can be calm and consistent while still being deeply strange. And this strangeness raises quiet questions. Does time truly end at the singularity, or does it continue in some hidden form? Could black holes connect to other regions of the universe, as some speculative theories suggest? Are they gateways or simply deep wells with no bottom? Science does not yet have answers, but it does have patience. Rather than forcing conclusions, scientists gather clues slowly. They observe how black holes affect their surroundings. They listen to gravitational waves. They study the faint glow of matter near the edge. Each piece adds to a picture that remains incomplete, but slowly growing clearer. In recent years, humanity has done something remarkable. We have seen a black hole, not directly, but through its shadow. In 2019, astronomers released the first image of a black hole's event horizon. It showed a dark center surrounded by a glowing ring of hot gas. The image was blurry and imperfect, but it was real. A quiet triumph. That image did not reveal what lies inside. It did not break the silence of the horizon, but it confirmed that these objects exist exactly where our equation said they should. Calm, massive, patient. It was a reminder that even the most mysterious things in the universe follow rules. And those rules are not rushed. Inside a black hole, the idea of inside itself becomes fragile. Spaces curve so deeply that the concept of a central location may not mean what we think. Some theories suggest that the interior is not a place but a process, transformation of space-time rather than a destination. If that sounds abstract, that's because it is. Black holes push us beyond everyday language. Words like inside, center, and before begin to lose their sharp edges. The universe becomes more like a flowing shape than a fixed map. This doesn't mean the universe is broken. It means our minds are used to gentler terrain. There is a quiet humility in studying black holes. They remind us that knowledge has limits, and that those limits are not failures. They are invitations. Each mystery encourages deeper curiosity, slower thinking, and greater care. Black holes do not demand attention. They wait. They wait for matter to wander close. They wait for galaxies to merge. They wait for scientists to build better instruments and better theories. They wait for time itself to unfold. And while they wait, they hold on to their silence. Nothing we drop into a black hole is truly gone from the universe's accounting. Energy is conserved, mass is conserved. Something remains even if we cannot see it. The universe does not lose track of itself. This quiet bookkeeping is comforting. It tells us that even in the darkest places, order exists. Even when light cannot escape, structure remains. Even when answers are hidden, reality continues calmly. Black holes are not chaos machines. They are extreme, but they are lawful. They bend the rules of our expectations, not the rules of physics. As we imagine drifting closer to one, we might expect fear. But what many scientists describe instead is awe. A sense of standing near a deep truth about the universe. A truth that is not loud or flashy, but steady and profound. Black holes show us what happens when gravity is given time. A lot of time. They are monuments to patience, sculpted by billions of years, shaped by equations that never rush. They remind us that the universe does not always move at human speed or human scale. Sometimes the most important things happen slowly, quietly, and far beyond our view. Inside the silence of a black hole, the universe is not screaming its secrets. It is keeping them, and maybe that too is part of the lesson. Not everything needs to be revealed at once. Not every mystery needs an immediate answer. Untruths are meant to rest, waiting for the right moment, the right tools, and the right understanding. Until then, black holes remain what they have always been: quiet, patient, and deeply, endlessly calm. How black holes shape the cosmos. Even in their quietest moments, black holes are never truly alone. They sit inside galaxies, wrapped in clouds of stars, gas, and dust, gently shaping everything around them. Their influence is not loud or forceful. It is slow, steady, and deeply patient, working over timescales so long that change feels almost invisible. To understand this, it helps to zoom out. Galaxies are not solid objects. They are vast, drifting systems made of billions of stars, floating in dark matter threaded with gas. Everything inside them is moving. Stars orbit the center. Gas swirls in lazy arcs. Over millions of years, these motions slowly evolve. At the heart of nearly every large galaxy, there is a supermassive black hole. This is not a coincidence. Astronomers once thought black holes were rare, unusual leftovers from dying stars. But as telescopes improved, a pattern emerged. Wherever a galaxy is large and mature, a massive black hole seems to be waiting at its center, quiet and unseen. These central black holes are enormous. Some weigh millions of times more than our sun. Others weigh billions. Compared to the size of their galaxies, they are still small, like a grain of sand at the center of a vast city. But their gravity reaches far, not in a dramatic way, In a guiding way, the black hole's gravity helps organize the movement of stars near the center. It acts like a deep anchor, holding the core together. Stars near the center move faster, pulled by the invisible mass. Farther out, the effect softens, blending into the combined gravity of stars and dark matter. This quiet influence helps keep the galaxy stable. When galaxies are young, they are messy. Gas clouds collide. Stars form rapidly. Everything is bright and chaotic. During these early times, black holes tend to grow more actively. They feed on gas drawn toward the center. As matter falls in, it heats up and shines, sometimes outshining the entire galaxy for a while. These phases are loud, but they don't last. As the black hole feeds, it also releases energy. Not as explosions, but as winds and gentle jets that push gas away. This feedback can slow down star formation, preventing the galaxy from burning through its fuel too quickly. In this way, black holes act like quiet regulators. They don't destroy galaxies. They help them mature. Once the galaxy settles, the black hole returns to its calm state. Feeding slows, light fades. The galaxy enters a quieter chapter of its life. Stars continue to orbit. Planets form. Time stretches on. Our own Milky Way appears to be in this calm phase. Sagittarius. A star, the black hole at our galaxy's center, is quiet now. It occasionally flares softly as small amounts of gas fall inward, but most of the time it rests. Meanwhile, stars continue their long, graceful orbits around the galactic center, guided by gravity that has been there all along. What's remarkable is how little black holes need to do to have such lasting impact. They don't need to act constantly. They don't need to consume endlessly. Their presence alone is enough to shape structure over time. This idea appears again and again in the universe. Galaxy clusters, the largest structures held together by gravity, often contain massive black holes at their cores. These black holes help control the temperature of enormous clouds of hot gas that fill the space between galaxies. Without this control, gas might cool too quickly, changing how galaxies evolve. Instead, balance emerges. Not perfect balance, but enough. Black holes also play a role in one of the universe's most subtle forces, gravitational waves. When black holes merge, they release ripples that travel across the cosmos. These waves pass through galaxies, stars, and even our own bodies, gently stretching and squeezing space by tiny amounts. We don't feel them, but they are there. Gravitational waves carry information about events that light cannot show us. They tell us about dark collisions in distant places. They let us listen to the universe instead of just looking at it. And once again, the message they carry is brief, a whisper, then silence. Over cosmic time, these whispers add up. They reveal a universe that grows through quiet mergers and slow rearrangements. Galaxies combine. Black holes sink toward new centers. Systems settle and resettle, never rushing, always drifting. This slow shaping challenges how we think about change. In human life, change feels sudden. Moments define us. Events happen quickly. But on cosmic scales, change is almost always gradual. Even the most violent events are brief compared to the long calm that follows. Black holes embody this pattern perfectly. They form in catastrophe, they shine briefly, and then they rest, shaping their surroundings through presence alone. Some scientists believe black holes may even influence the large-scale structure of the universe indirectly. By affecting how galaxies grow, they affect how matter clumps. These clumps shape the cosmic web, the vast network of filaments and voids that stretches across the observable universe. Seen this way, black holes are part of a much larger story. They are not isolated oddities. They are threads woven into the fabric of cosmic history. This perspective changes how we feel about them. Instead of fearing black holes as destroyers, we can see them as participants. They're extreme, yes, but they follow the same rules as everything else. Gravity pulls, energy flows, time passes. Nothing is wasted, nothing is rushed. There is also a poetic symmetry here. Black holes are born from stars, and stars are born from clouds shaped by galaxies, which are shaped in part by black holes. The universe recycles itself through these quiet loops, turning endings into beginnings over and over again. Even the darkness of a black hole is not truly empty. It is full of mass, full of gravity, full of influence. And influence does not require noise. This is perhaps one of the most calming lessons black holes offer. Power does not need to announce itself. Importance does not need constant action. Sometimes, simply being in the right place, holding steady, is enough to shape everything around you. As the universe ages, black holes remain. Stars will burn out. Galaxies will drift apart as space expands. The sky will grow darker. But black holes will still sit in the quiet, slowly evolving, slowly changing, barely noticeable unless you know where to look. They will continue shaping motion, guiding orbits, holding on to mass. Long after the loud chapters of cosmic history have ended, black holes may still be there, anchoring what remains. And in that far future, the universe may become a very quiet place indeed. But even then, black holes will not feel lonely. They will be doing what they have always done, waiting, shaping, holding the universe together, not through force but through patience. The long memory of gravity. As the universe continues to age, black holes become quiet record keepers. They do not write history in words or images. They store it in gravity. Every star that ever fell in, every cloud of gas that slowly spiraled down, every merger with another black hole adds to their mass. In this way, black holes carry a memory of the past, not as stories, but as weight. This memory is simple but powerful. Unlike stars, black holes do not burn fuel. They do not shine themselves away. Once mass becomes part of a black hole, it stays there, locked in place behind the event horizon. Over time, this makes black holes some of the most reliable archives in the universe. Quiet archives. In the early universe, everything was brighter and closer together. Galaxies collided often. Gas was plentiful. Black holes grew faster during this time, feeding more actively as matter flowed inward. These early feeding periods helped shape the galaxies we see today. As the universe expanded, things slowed down. Galaxies drifted farther apart. Gas became harder to gather. Star formation decreased. Black holes once again settled into long periods of rest. This slowing is not a failure. It is a natural rhythm. The universe does not rush toward complexity forever. It builds, peaks, and then slowly relaxes. Black holes fit perfectly into this rhythm, growing quickly when conditions allow, and waiting patiently when they do not. In the far future, this patience may become even more important. Stars will eventually exhaust their fuel. New stars will become rare. Galaxies will grow dim. The universe will cool as it expands. In this fading light, black holes may stand out not by shining, but by remaining. They will still have mass. They will still curve space. They will still influence motion. Even when almost everything else grows quiet, black holes will quietly persist. Some scientists imagine a universe billions upon billions of years from now, where only a few types of objects remain: cold stellar remnants, thin radiation, and black holes drifting through vast emptiness. In this future, black holes may slowly change through Hawking radiation. This process is incredibly gentle. It does not look like fire or sparks. Instead, it is more like a slow leak of energy from the edge of the event horizon. Over immense spans of time, black holes lose mass, grain by grain, as if exhaling the faintest breath. For a black hole as massive as the one in our galaxy, this process would take far longer than the current age of the universe. Time, beyond time. But if the universe lasts long enough, even these giants may fade. What happens then is still uncertain. As black holes shrink, they grow warmer. Their radiation increases. At the very end, they may disappear in a final soft release of energy. Not a violent explosion, but a brief bright moment followed by nothing. Even their ending is quiet compared to their beginning. This idea that black holes eventually vanish adds a gentle symmetry to the universe. Things form, things endure, things slowly dissolve. Nothing lasts forever, not even the darkest objects we know. Yet even this fading takes patience. Black holes do not resist time, they move with it. There is something calming about this. In a universe often described as cold and empty, black holes show us a different side. They show endurance without struggle, power without aggression, presence without noise. They are not mistakes in the universe's design, they are outcomes. Natural results of gravity given enough time to work. This understanding changes how we feel about darkness itself. Darkness, in this sense, is not evil or destructive. It is simply the absence of light, shaped by laws as gentle and consistent as those that create stars. Black holes remind us that light is not the only form of existence that matters. Gravity matters, time matters, waiting matters. When scientists study black holes, they are not just studying exotic objects, they are studying the limits of understanding. Black holes sit at the intersection of gravity, time, space, and quantum physics. They force our theories to talk to each other, even when they disagree. In this way, black holes quietly guide science forward. They don't offer easy answers. They offer deep questions, questions that cannot be rushed, because rushing leads to mistakes. Progress comes slowly through careful thought and long observation. This mirrors the way black holes themselves behave. Slowly, carefully, unapologetically patient. Even the tools we use to study them reflect this patience. Telescopes gather light over many nights. Gravitational wave detectors listen for years, waiting for tiny signals to pass through Earth. Data is sifted gently, patterns teased out over time. Discovery does not come in bursts, it comes in whispers. And each whisper adds to our understanding of how the universe holds together. There is also a quiet emotional effect in thinking about black holes this way. When we imagine the universe as violent and chaotic, it can feel overwhelming. But when we see how much of it is calm, structured, and patient, something softens. The universe is not in a hurry. It does not demand urgency from us. It allows room for stillness. Black holes, despite their reputation, are among the strongest symbols of this stillness. They show us that extreme conditions do not require extreme behavior. That stability can exist even in the most intense environments. This is not a lesson about physics alone. It is a reminder that depth does not need noise, that meaning does not need speed, that some of the most important forces work slowly, invisibly, and without announcement. As we move toward the final part of this journey, we carry this feeling with us. The universe is vast, but it is not careless. It is old, but not exhausted. It is quiet, but not empty. And at its darkest centers, black holes continue to wait, holding memory in mass, holding time in curves, holding the cosmos together, not with forceful motion, but with endless patience. In their quiet lives, black holes reflect something profound about reality itself, that even in darkness there is order, even in silence there is structure, and even when nothing seems to be happening, the universe is still, gently becoming. When the universe grows quiet. As we look far ahead in time, the universe begins to change its mood, not suddenly, not dramatically, but slowly, like evening light fading into night. Galaxies drift farther apart as space itself stretches. The energy that once fueled bright stars becomes harder to gather. New stars are born less often. Old stars burn through their final fuel and settle into quieter forms: white dwarfs, neutron stars, and black holes. In this aging universe, black holes become more noticeable, not because they grow louder, but because so much else grows silent. For most of cosmic history, stars dominate the scene. They shine, they warm planets, they light up galaxies. But stars are temporary. Even the longest living ones eventually fade. When they do, the universe loses much of its visible light. Black holes, on the other hand, do not rely on fuel. They simply remain. As billions of years pass, galaxies become dim islands in an ever-expanding sea of darkness. Collisions become rare, interactions slow. The universe relaxes into a quieter, emptier state. This future is sometimes called the Dark Era. It sounds ominous, but it is not violent. It is calm. In this era, black holes may be among the most massive and influential objects still active. Not active in the sense of doing things, but active in the sense of shaping motion. Objects that wander too close still fall inward. Orbits still curve. Gravity still guides what little movement remains. Everything just happens very slowly. Time, by human standards, almost stops mattering. Millions of years feel brief. Billions feel ordinary. Change stretches across unimaginable spans. In this long quiet, black holes may quietly merge again and again as the last galaxies slowly drift together or collapse inward. Each merger adds mass. Each merger releases a final whisper of gravitational waves. Then silence returns. Eventually, the universe may reach a point where black holes are some of the only complex structures left. This idea can feel unsettling at first, but there is also a strange peace in it. The universe does not collapse into chaos. It does not tear itself apart. It cools, it thins, it rests. Black holes fit naturally into this ending. They are not intruders. They are outcomes of gravity doing what gravity always does when given enough time. Even in this far future, black holes are not eternal. If Hawking radiation is real, then black holes slowly lose mass over time. This loss is incredibly slow for large black holes. So slow that for most of the universe's life it barely matters. But given enough time far beyond stars, far beyond galaxies, even black holes may fade. What's important is how gentle this process is. There is no collapse, no sudden disappearance, just a gradual release of energy, spread thin across the cosmos. A final soft glow, then nothing. This is not destruction. It is completion. In this way, black holes participate in the universe's long story of balance. Matter clumps, matter spreads, energy concentrates, energy disperses. The universe moves between structure and simplicity, never rushing, never stopping. Some scientists describe this future as a heat death, where energy is evenly spread and no useful work can be done. But even this phrase can sound harsher than the reality. The universe is not dying, it is settling. Black holes help us imagine this settling without fear. They show us that even the most extreme objects follow gentle endings, that permanence is not required for meaning, that even the deepest darkness has a quiet arc from beginning to middle to end. There is also a humbling lesson here. Human life is brief, civilizations are brief, even planets are brief. When we measure ourselves against black holes, we see how small our timescales are. But instead of making us feel insignificant, this perspective can be calming. We are part of a much larger rhythm. The universe does not rush us. It does not demand that everything happen quickly. It allows time to stretch, to soften, to carry things forward at its own pace. Black holes embody this patience more clearly than almost anything else. They wait without boredom, they endure without effort, they change without urgency. In a way, black holes teach us how to think about endings differently, not as failures or losses, but as natural transitions. Stars end and become something else. Galaxies evolve and thin out. Even black holes, given enough time, may return their energy to space. Nothing is wasted, nothing is panicked, everything flows. As we imagine this distant future, the universe feels less like a battlefield and more like a quiet landscape slowly settling into rest. Motion becomes rare, events become subtle, silence becomes common, and still, gravity remains, space remains, time remains. The laws that shape the universe from the beginning continue to operate even when there is very little left to shape. Black holes, in this sense, are not just objects, they are reminders. Reminders that the universe is built to last, not through constant activity, but through deep stability, through rules that hold even when everything else fades. In the end, the quiet life of black holes is not just about black holes. It is about the universe learning how to rest, and in that rest there is no fear. Only patience, only balance, only a deep, gentle calm that stretches across eternity. The quiet lesson they leave behind. Everything is said and done. Black holes do not feel like endings, they feel like pauses. They sit at the far edges of our understanding, not shouting answers, not demanding attention, simply existing as they are. In a universe filled with light, motion and constant change, black holes represent something different. They represent stillness that lasts. This stillness is not empty, it is full of meaning. For a long time, humans feared black holes. We imagined them as destroyers, cosmic monsters waiting to swallow everything. But the more we learn, the more that fear softens. Black holes are not hunters. They are not chasing the universe. They are responding to gravity, patiently and exactly, the same way the universe always has. They form when matter is too dense to remain a star. They grow when something wanders too close. They rest when nothing does. There is no intention behind them, only balance. This realization quietly changes how we see the universe itself. It is not built on drama alone. It is built on laws that favor calm stability. Even the most extreme objects obey gentle rules, followed over long stretches of time. Black holes are proof of this. They are places where space bends deeply, where time slows, where light cannot escape, and yet nothing breaks. The universe does not panic when it creates a black hole. It continues calmly, adjusting around it, letting gravity do what it does best. Over billions of years, black holes have helped shape galaxies, guide stars, and sculpt the large-scale structure of the cosmos. But they did this without noise, without urgency, without forceful motion, just by being there. This may be their greatest lesson. Not everything meaningful needs to be loud. In a world where we often equate importance with speed and volume, black holes offer a different message. They show us that patience can be powerful, that stability can matter more than action, that waiting is not the absence of progress, it is a form of it. Black holes wait for time to pass because time always does. They wait for matter to drift close because eventually something will. They wait for the universe to change because change is inevitable. And while they wait, they hold on to what they're given. Mass, energy, memory. They do not rush to give it back. They do not resist. They simply hold. Even the idea that black holes may slowly evaporate reinforces this calm perspective. Their final act is not destruction but release. Energy returning to space so gradually that the universe barely notices. No fireworks, no collapse, just a gentle unwinding. When scientists talk about the far future of the universe, the words can sound cold. Dark era, heat death, entropy. But when we look closely, the picture is softer. The universe is not ending in chaos, it is settling into equilibrium. Black holes are companions in that settling. They show us that permanence is not required for significance, that even the longest-lasting objects eventually change. And that change does not have to be frightening. It can be quiet. There is also something deeply humbling about black holes. They remind us that the universe does not revolve around observation. Most black holes will never be seen. Most will never interact with anything meaningful again. They will simply exist, unnoticed, for longer than stars, longer than galaxies, longer than any civilization, and that is okay. The universe does not need an audience to function. This thought can feel small at first, but it can also feel freeing. It suggests that meaning is not something granted by attention alone. It exists naturally, woven into the structure of reality itself. Black holes matter even when no one is watching. In studying them, humans have learned to slow down, to listen for faint signals, to wait years for a single detection, to accept that some answers will not come quickly, or at all. This patience has shaped science just as black holes shape galaxies. We build instruments that listen instead of shout. We trust math that predicts before it reveals. We accept mystery without forcing conclusions. Black holes teach us that understanding does not come from rushing toward the unknown, but from standing still long enough to let it reveal itself. And perhaps this is why they feel calming once the fear fades. They remind us that the universe is not hostile. It is indifferent in the most gentle way. It allows complexity to arise. It allows it to fade. It does not cling. It does not resist. It simply follows its rules. In the quiet life of black holes, we see a reflection of the universe's deepest character. Not violent, not cruel, but steady, lawful, and patient beyond measure. As this journey comes to an end, nothing dramatic happens. There is no final explosion, no grand conclusion, just a sense of deep time stretching onward, carrying black holes, stars, galaxies, and eventually silence itself. And somewhere within that vast calm, the universe continues to exist exactly as it always has, quietly becoming what it must. Black holes do not demand that we fear them. They invite us to slow down, to listen, to accept that some of the most powerful things in existence move gently, wait endlessly, and speak only in whispers. And in that whisper, if we're patient enough, we hear something reassuring. The universe is not in a hurry, and neither do we have to be.